it is asking us to find the average velocity of the sled for the entire ride. So what happens here is that each segment is going to have an average velocity. So we need to find all the average velocities at every segment, then find the total average. I will begin with this formula, and I will rearrange it so it will be easier for me. So I'll just keep using this formula over and over again. So beginning at the 30 seconds to 60 seconds. We already found this to be 25.4 meters per second. Now, this is the final velocity. To find the average velocity, we need to do final velocity plus initial velocity divided by 2 will give us the average velocity. Okay? So this is the other equation that I will continue to use. This was for the first segment. Our second segment will be, again, going back to this formula. Final velocity for this time segment is 25.4 meters per second. This becomes the initial velocity for 60 to 90 seconds. So the initial Okay, now for each segment, I have found the average velocity. First, I began by finding the final velocity for each of them, while we have their initial velocity right here, using this equation, and then afterwards, I use the final velocity plus initial velocity divided by 2 to find the average velocity. I'm going to add all of these velocities. That this is the average velocity for the entire ride. What is the average acceleration of the sled for the entire ride? Acceleration equals to the change in velocity over the change in time. So it would be A equals to Vf minus Vi over the change in time. So what we can do here is just plug in our numbers to find A. So A equals to Vf, which our final velocity from question 6 we found to be negative 3.4 meters per second, minus the initial velocity, which we were given in the description of the problem, and divide that by our time. Final time is 180 and our initial is 30 seconds. So divided by 180 seconds minus 30 seconds, which will give us that acceleration is equal to -0.3 0.096 meters. What must the velocity of the sled be at 30 seconds so that the snowman comes to rest at the end of the hill? In the problem, they told us that the beginning velocity was 11 meters per second. Now they're asking us to find what the velocity would be here at the 30 seconds if he were to stop here. If he were to stop at the end, he does not stop at the end of the hill because we know that he's going negative 3.4 meters per second. Use the impulse momentum theorem. So it says that the change in momentum equals to m times final velocity minus initial velocity. And now because I have this negative right here, I'm going to multiply everything by a negative or divide either way. Then this will give me negative change in momentum over mass. The VF becomes positive and the VI also becomes positive. So now let's just plug in the numbers. We have negative 360 over m plus 0, which this is because he comes to a stop, so he will have 0 meters per second velocity. Let's not forget that this becomes positive, so if we want to just make it more clear, it was 14.4 meters per second. Okay? So, in order for the snowman to stop right here at the end of the hill, he needs to begin at the beginning with a velocity of 14.4 meters per second. So 11 meters per second caused him to continue. However, if he begins with 14.4, he will stop